Today we're going to talk about exceptions and what they're used for and how you can use them and how you can create your own exceptions and so on. I would guess that some of you are familiar with exceptions from other languages. Is that the case? All right. If that is the case, then this should be mainly review. So good. It should be mainly review. And hopefully this will cement what you already know and sort of maybe even add to it in some respects. So let's start out. What are exceptions used for? Yeah, you can have exceptions for a couple of things. I think what you're getting at is you can have exceptions for a couple different things. One of the things you can have exceptions for are user errors. For example, if you were doing a payroll calculation and someone entered in a negative number of hours, all right? Now you might ask yourself, wouldn't that be in the GUI to do a test to make sure? And the answer is yes. But we're going to be like the guy that wears suspenders and a belt at the same time, right? Because what we want to do is we want to make sure our object is rock solid. So therefore, we don't want to rely on the GUI having all the validation in it. We'll put validation in it, but we'll also have that last catch because we never know what our classes are going to be used for. They could be used for something else totally different. All right. We are going to then use exceptions to handle user error and other unforeseen errors. The way I would like to put it is we will use exceptions for errors that we have no control over, all right, and errors that we can do something about. Now, what we do depends on the exact context of the error. That's why typically I'm going to have my business classes throw the exception, and I'm either going to have my program, my boss class, our unit test class, or later on our GUI will handle them and display them. Because we don't necessarily always want to do the same thing if something is invalid. Let me give you an example. We might be reading students from a date. We might be processing students two different ways. All right. We might be processing students through the use of a GUI where we key in their ID, it retrieves it from the database, creates a student object, we do our thing, and then we go and update the student object. All right. And we might do it as part of a batch job where we process a whole bunch of changes. Like, for example, at the end of the semester, when grades are finally posted and degrees are earned. All right. Something probably goes through and looks at a bunch of things, not something that's keyed in, but looks through and automatically makes some updates to the student class. So the same student class could be used as part of an interactive application and a batch application. Well, in both of those cases, in the case of a interactive application, you can pop up an error message and say, hey, you entered in the residency code incorrectly. All right. However, in a batch operation, you can't do that. If it's retrieving data, if it's processing through thousands of students, you can't pop up something on a screen. There is no screen. All right. It's just something in process that's running. In that case, you might want to write your error message to a log file and say this student wasn't processed because such and such. And then people later on can review it and fix it. So you might want to react to errors different ways depending on the exact situation you receive those errors in. So we're going to have the class throw the exception, and we're going to have the unit test, and then later on our GUI process the exception, or catch the exception, I should say, use more of the correct term, and display it. All right. What are things that we don't have control of? Well, you hit on one, definitely. We don't have any control on user input. We can tell the user over and over again, you have to enter a number here. Guess what? Some user isn't going to enter a number there. All right. and it shouldn't crash your program. So far, we've sort of ignored this, and we pretended that in our unit test class, everyone's going to do things by the book, right? When we had residency codes, you made sure that they were the 3 possible values, all right? You can't depend on that in a real application. Again, even if you have a GUI that's forcing and validating for that, you still want the exception thrown because, again, it could be used in some other situation. So user input is something that you don't have control over. Input output, like writing to a file or writing to a database, is something you don't have any control on. You might write a perfect program, but the database server is down, in which case you're going to get some kind of error when you try to do a database operation. Not something that you could account for, all right? Not something you can work around in your code, but it's a problem you have to deal with that you don't have control over, all right? So I'm going to go over examples of exceptions, and we're going to look sort of from the very simplest case to a more involved case. And we're going to start out with exceptions that the Java system throws just on its own. So I have this test exceptions file. I'm going to open it up, and we're going to see what it does. It's funny. I have these examples, and I know what they do, but I don't remember exactly how to do it. All right. Here's an example. And I'm going to cut out the try catch, just to show you what happens without the try catch. Now, this is a very contrived example. What I'm doing is I'm creating an array list of strings. I'm adding 2 strings to that array list. I then am looping through the array list for I equal to 1 to 100, which is bad, right? All right, because there's not 100 different things in this array list. There's only 2. So we should do it either 2, which wouldn't be really good. We should get the size of the array list and do it that time. But we're doing something, we're throwing a monkey wrench in it. If I is equal to 1, we're nulling out. We're setting that string to null. So we're going to have a null object exception. So let's go and save this. And let's go and run it. Okay, we're in that. We're going to compile it. And we're going to run it. All right, first rule. All right, this threw a no pointer exception. Why? Well, because we set element 1 to a null. So that object is null. Therefore, it printed 5 for that's the length of hello. But when it hit object in position 1 in the array list, it's a null object, and you can't get the length of a null object. So it prints this error. Now, first rule of exceptions. Someone has to take care of it. Someone has to clean up the mess that was created. And you got two choices. All right. You or the Java virtual machine. And the Java virtual machine is not going to deal with it gracefully. It's going to blow up. All right. It's going to stop execution of your program, output a message, and away you go. Now, we could change that, all right, to handle it ourselves. Then, again, if we were reading from a file, we could write to a log file that says that there are an error log that says that we encountered an error with such and such piece of data or something along those lines. But we wouldn't have to stop processing the whole file then. All right. So let's go back to the code and let me put back what I cut out of here. Where we have a try catch. Inside the try are the statements that we think are suspicious. By suspicious, I mean prone to error. By prone to error, I mean things that are sort of outside of our control. Now, in this case, I don't know if this is a good example of this, because we arrange for there to be an error, but, it's always good to test if something is null or not before you do something with it. So, we actually have two different exceptions. One is that there's a null pointer, that this list set, or this get sub I is going to return a null object, which we're setting to the one in position 1. The other possibility is we're doing this 100 times. The other possibility is that we didn't initialize that variable at all. Therefore, we're outside of the bounds of the array. There is no I sub 2 through 99 in this case. All right. There's only element 0 and element 1. How did the null exception happen? Let's go back to how it was. Yeah, I said print out the length, and this get I returned a null object in the case of 1 because I nulled it out. All right, and therefore a null object has no length and it blew up. Now what I'm going to do is I'm going to get 98 of this error, index out of bounds, and I'm going to get 1 null object for position 1. So let's save this and recompile it. And sure enough, there we go. Null string at position 1, invalid index at position 2 through 99, just as predicted. All right. Now, we can catch errors two different ways. One way is by catching the specific exception that's generated. Another way we can do is we can simply say catch exception B. If we do that, we can't differentiate between what kind of exception it is. Because if we say catch exception, it will catch anything of that type. It's all based on types. And all the exceptions inherit from exception, the exception class. Pardon me? It's a superclass, and they're all subclasses of that. So now when I do this, yes, thank you. Remember, in general, we want to get compile errors, not runtime errors. This is an aside. Because we're only testing for exception and not looking at the various subclasses of exception, we can't differentiate and say what the problem is. Because this gets thrown whether it's out of bounds, index out of bounds, or if it's a null object. Sometimes that might be okay. All right. Other times you want to know specifically what the problem is. All right. So there's no fixed answer to say one is better than the other. Oh, it does. Yeah, that's a good point. And if we were only interested in displaying, a message, we could do this. So you're right. I didn't lie. I just didn't explain it completely. There we can tell one's an index out of bounds, The first one will be null. So you can do that. All right. Where you lose is what if you wanted to do two very different things? Like in one case, for one kind of exception, you wanted to maybe, let's say just for laughs, that for null pointers, we're going to replace that with a string of spaces. All right, in our array list. All right. So I could do this. I'm going to default this. This will give us a message. If all we were interested in is displaying the message, this would be fine. But what if we wanted to do something like this? Out of bounds, we're going to display a message. For null, we're going to set that to an empty string, which is different than a null. Then we're going to output the length. So we might want to do two very different things depending on the exception, depending on the type of exception. So that, I guess that would be my gauge of whether I would test for specific exceptions or just test for the general exception. If I was always doing the same thing, like displaying a message, I might as well just test for exception. I can, because as you mentioned, you can pull that attribute out, saying the type of exception. But if I wanted to do different things depending on the exception, then I would check for the individual exceptions. I can then have as the very last one on this list, catch exception. So this will do this. It will set it to an empty string and get the length of the empty string. This will simply display this message. This is any exception that isn't these two. All right. Well, let me go in. Now it displays a message for those. For the second row, it says the exception is 0. Going to 0. Because I didn't put anything in there. I didn't put a space in there. So it's an empty string, which again is different than a null. All right. Confusing. All right. Yes. Well, this comes along. This gets an exception. Notice where the exception lives. The exception lives inside the loop. So the loop will continue. All right. This will loop through for all of the things. But you're right in that when you get the exception, it is going to, if there were other statements here, and the first line or the nth line or whatever, this stuff does not get called. It's sort of like at that point, you know there's a problem. So this particular piece of data is not worth processing any further. Give you, for example, let's say you're doing a payroll calculation and you had set hours. You might throw an exception if the hours were negative. All right. Now, if the hours are negative, you want to stop processing that person. You don't want to go and continue to calculate their payroll, because they'd end up with a negative gross pay, a negative net pay, and all kinds of problems would ensue from that. So therefore, it's like, hey, we got a problem. We're going to stop. Now, if we did this, I know this isn't what you asked, but I'm going to answer it. If I included this, it will execute one timeout exactly. Where indenting comes in. I'm already confused. This should be, yeah. Right. Right. I still don't think I have a 100% correct. Yeah, the try block would include the loop And then we have the catch blocks here. No, they're caught as they occur. And again, if the try is in there, if the try is inside the loop, it will continue the loop. But if the try is around the loop, then this should only go through one example. I hope I did everything right. Oh, I have to close the loop. And then the try ends there. Yeah. And the final. So, but, but I am get also a good level. How does those hold on, let's think about those things so they can use it. The can be either so stop after stop after this. One of the in other words, you're kind of asking to die while processing one or while processing. Processing to processing that. processing one. Okay. Let's go on to the next thing. This example, I will assign I'm trying to find going back to my geometry. One thing that you can say for the final group thing, each side is less than the sum of the other. So my definition of that would be all of this make sure that the constructor I might get respect to the property. As a constructor, I set all these sides. Then I look to see if side one is greater than side one plus side two, or C is greater than 1 to 3, or C is greater than 2 to 1, then it's an exception. Each side must be less than some of the other. I also have on set throwing an exception if side is a negative balance. Well, that's one of the things. You're right. If I had a triangle that was 10, 5, and 5, that's not a triangle. That's one problem. All right. I'm testing inside of it's negative. Then I have a get. Then I have a get term, which comes up the side. Here I'm going in and creating the finder. All right. I'm trying to create it with a new integer of hello. Right. I create a new integer. By the way, this process, notice I'm creating an integer object, even though this requires an int. And that's the whole idea of boxing and unboxing. This integer object is linked with an int property so that we it automatically be converted into an int. I'm not sure. Okay, I'm trying to create it. I'm not sure. Looking for no pointer. Looking for a number format exception. And I'm looking for other exceptions. Complain about something being deprecated, which because this is pretty fried, and I'll be worried about that. All right, I get a we have for input string hello that we have code specifically ready for number thing. So that's that. Say I do put something will make it 7. No. That should not be valid. So 7, 1 is 8. Greater than. Yes. And if you're an exception, and the message is the message that I created. This example is different than the other example I went because this throws and exceptions. The other one, all I have is a try catch. In this one, I have try catches and throws. All right? You can throw an exception like this. By testing some tests, if there's a problem, you can throw and create a new exception object of whatever type you have, set the message of it, and then you have to indicate that its function is throw. Same thing to these functions. I'll make that negative 7. Okay. Row exception. The business class or the problem domain class throws the exception. The UI or the unit test class, whoever the boss program is, boss class, is going to catch it and do something with it. Because again, in different cases, you might want to do different things. Now, in this case, I threw my own exception that I created. All right. But even though there's different real problems, I, in both cases, just create an exception. And again, that's fine if all I want to do is display it. So any other exception that gets thrown in addition to the ones that I'm throwing that are not these two are going to get called by this code. So if there was a database exception, it would hit this code if we were doing this connected to a database. All right. There are two kinds of exceptions. They're called checked and unchecked. Checked exceptions are exceptions that could occur, that we know could occur, and we have to have a catch that handles it. Somewhere down the line, it has to be handled. So, for example, in this case, how do we get rid of this? I'm going to get a compile error. Why am I going to get a compile error? Because this function says that it's going to throw an exception, yet nowhere am I catching that exception. Unreported exception must be caught, declared, be thrown. Right? The other kind of exception is unchecked exception. Those do not have to be, the compiler is not going to check those. If it inherits from exception, it is a checked exception. If it inherits from error, it is an unchecked exception. Error scenarios are outside the immediate control of the program. Yeah, that would be something like database errors and all that. You still can catch them if you want to, but you don't have to catch them. You can just let it blow up. Whereas checked would be something that like maybe is within control of the program. Repeat that, please. I don't know. All right. Right. Blah, blah. Index outlet way. And so out of bounds. If a function throws that, you would have to catch that. So that inherits from exception. That's the exception. I'm calling up JavaDoc, though these are a little hard to read, but these are the most comprehensive documentation that is there. Known subclasses. This is a database thing, AWT-air, Red Death, sounds deadly, IO-air, and so on. These are not, these are unchecked exceptions. The last example I want to look at involves me creating my own exception classes. Now, the problem with this version version 2 is that all this is doing is throwing an exception. That might be good, but when our catch, we have a catch-all to catch all the exceptions that aren't these two. And again, in a different program, there could be more than these two possible exceptions. So what we can do is we can actually define our own exception classes. They're called triangle exceptions in this case. Something I made up, and I now say that this does not throw just a plain old exception. It throws a triangle exception. And the triangle exception is going to inherit from exception. But I could put in there all kinds of things that are all kinds of other attributes. I could put in here attributes for the side to display the values for the side. All right. I could definitely set the error message with a string. But I could add whatever would be necessary the time of day that this triangle had a problem. Anything that I would want to add to the normal exception, I could add here. And then I could, it's the wrong one. Then I could check for it. Triangle exception. I could even define separate triangle exceptions where the sides are set wrong, or where the total of the sides are set wrong, whereas each side is not less than the sum of the other two sides. I could create a triangle exception and have things inherit from that. Make it an abstract class and then have two exceptions inherit from that. Now, here is the question though. All right. Where you already pointed out one bug, so that's good. It should have been less than or equal or greater than or equal to. What's the other bug in this code? This is a different version of it, so I'll make the other correction. No, this comparison is correct. I'll tell you what, the problem is in this function, in the set sides. That's correct, less than 1, because that's an integer, all right? So it couldn't have a 0.5. So less than 1 is valid. What's not valid is after every set, I should recheck this, right? Because I could set a triangle as 5, 5, 5. That's a proper triangle, and then set 2 of the sides to be 1 and 1. All right, where it would not be a proper triangle. All right, so it would work initially, but it would fail if I called the constructor, set them right, and then later called a set that messes things up. So I just realized that now. I probably would create a function. I'd probably put this code in a function that evaluated that. And then I would call that function, have that function also throw a triangle exception, and then call it from the constructor, call it from here, and call it from there and there. Well, the thing is that we have to set these, we have to set side one. We have to set them in a certain order. We set side one, it's going to be wrong right off the bat, right? It's going to think it's wrong. So therefore, we have to check it in the constructor as well. All right, good call though. All right. Are there any questions over this? Okay. We will see you next week.